Okay, a small update of the working of the indicator module, or if some people like to call it the SOC, in the SOC state of charge indicator, or SOC module, whatever you want to call it. The way I built it was with the idea to have a visualization of what the state of charge is of the batteries or the single cells in a row. So as you can see now, I have my power source set to more than 4.2 voltage, which means over voltage. And as you can see in the LED here, the LED is blue. So in my case, blue means overcharge. If I let the voltage go down, what I'm doing now, at least trying, as you can see, when the voltage goes down, the other LEDs gonna light up, like in this case green. If I go down more, there's 4 green LEDs, 1, 2, 3, 4. And then if the voltage drops even more, you have the 3 orange or yellow ones, which tell you, of course, a visualization of what the state of charge is, the SOC. And if it drops even more than 3.3 voltage, in my case, it goes over into red, not so good visible in this, because my camera, I can't regulate the light source and everything. What you can see now, it's 3 voltage, and if it drops even lower than 3 volts, it goes out. So the way this is working, it is, if it's not lighted up, it's under voltage. If it goes up, you have the 2 red LEDs, as you can see here. Then it goes over in 3 orange or yellow LEDs as the voltage raises. And then you have the 4 green ones, which you can see is very bright, but it is what it is for now. And when it goes even more up, like you can see it's more than 4.2 volts, it goes over to blue, and this means overcharge. This is the way it is for now. Maybe in the future or the near future I can change this, that if the blue one goes on, you have a buzzer which is going to give an alarm or something with a relay. But the really question is it really necessary to put an alarm in there? Because if you have a good BMS, battery management system, that one should take over all this. So actually this board is just a visualization of what the SOC is, or state of charge, and you have a quick visual on what the state of charge of the batteries are. In my case, as you can see, this is all 1 bar readout, or in other words, it's only 1 LED going on and the other one goes off. So there's only 1 LED on all the time, or sometimes 2 when it is between 2 voltages, which are for the IC not as good to translate, but as you can see, it's only 1. If you want all the LEDs to go on, there is a small jumper, I call it jumper, or it is the GP1 up to 7. If you want all the LEDs to go on, I will show you. You have the jumper, oh, wait a minute, focus. The jumper here, this one, if you solder this together, all the LEDs will go up and down, and then of course the consumption of electricity, or what the board is going to consume, is going to be more. In this case it's only about 7 milliamps per LED, and if you use all 7, it's going to be 49, or let's say 50 milliamps an hour that it's consuming. If you put all the LEDs on, it's going to be around, I think 50 milliamps per LED, multiplied by 7, then it's going to be 350 milliamps, so that's a bit more. But this is the first board of this kind, and the future models will have some more features, but still it's gonna be a visualization. It's not to take over the BMS, as some people want some more features on there of an alarm and a voltage meter or a LCD display. This is to have a quick visual on the state of charge or the SOC of the battery pack you have. And some more versions will come out of it, but it has to be or it has to stay simple in use, and it's still a visualization of what the state of charge of your battery pack is. And that's it for now, so on to the next video.